This is a video for how to go about understanding and utilizing geometric sketch constraints in Autodesk Fusion. To understand geometric sketch constraints, we will first have to start a sketch. So we're going to click on Create Sketch, and we're going to choose the XZ plane. I want you to notice that anytime I select a plane here, you can see in the Origin menu which plane I am selecting. So we're going to choose the XZ plane. And starting a sketch, just recall if you've made it parts in Fusion before, we've generally utilized the Create menu where you can do almost anything you could do with a pencil, and then in the Modify menu you can modify anything that you used in the Create menu, filleting, offsetting, trimming, etc. In this video we're going to learn how to take anything that you might have made or modified in the Create or Modify menu and put some constraints on those that are geometric. There's two different types of constraints in Fusion, geometric and numeric. Numeric is like the distance of a line, the radius of a circle. Geometric constraints are ways we can force that geometry to only exhibit a certain behavior. And you'll notice that when I click on the constraint menu, all of the different types of geometric constraints are listed, and also they have the icons that represent those geometric constraints next to them. You'll also find that up here in the toolbar where all I have to do is click on any one of these icons to get that type of geometric constraint. To start understanding geometric constraints, we're going to start with the horizontal and vertical geometric constraint. I'd like for you to click on the line command, and I want you to sketch a diagonal line that's more vertical than it is horizontal, and then I want you to sketch another diagonal line that's more horizontal than it is vertical. If that makes sense, maybe to make that make a little bit more sense, it would be easier for me to make this stand up straight than lay down, and it would be easier for me to make this one lay down more than stand up straight. To utilize the vertical or horizontal constraint, we're going to click on this icon, and we're going to come out and we're going to click on our first line, and you'll notice it stands up straight because it's more vertical than it is horizontal. When I come over and click on this line, it's going to only have itself be a constraint to where it's only horizontal. Notice that the horizontal and vertical constraint, geometric constraint icons show up. The same icons you see here are right here on the sketch plane. Let's right click and say OK. I'd like for you to notice that I can't drag these up and be diagonal. They have to be horizontal. I can't drag this over and lay it down flat. The only behavior it will have is to be vertical or horizontal. Our next geometric constraint is going to be coincident. And what coincident does is it forces two lines or 2 points to meet. So if you saw somebody somewhere and you say, man, what a coincidence that we bumped into each other, this is the same kind of concept. A coincident constraint would force 2 points to touch. So to understand the coincident constraint, I'm going to click on this point at the end of our horizontal line and click on the bottom point of our vertical line, and I want you to notice that they now touch. They will always touch for as long as we have that constraint in place. Notice that they will always stay together no matter where I drag. So if I drag this line down and through, these will always touch. There is a coincident constraint. You have now told that never to move unless we tell it otherwise. For our next understanding, for our next geometric constraint, we're going to utilize the tangent constraint. And in order for us to understand the tangent constraint, we are going to sketch for ourselves a circle. So somewhere, let's have our L shape right here, and let's just sketch ourselves out a circle of any size. And what we want for tangent to understand is that what tangent means is that this circle will touch a line or another arc or another circle or really any other geometry at one point, and it will not go all the way through it. So for tangent, let's click on the tangent constraint, and you have to click on the outside edge. You don't click on the point in the middle, you click on the actual circle itself. And I'm going to click on our circle, and I'm going to come down and click on our horizontal line. And I want you to notice that the line and the circle are now tangent. We're going to go ahead and do the same thing over here on the vertical line, but let's click on my vertical line and kind of drag it up a little bit. I'm going to drag down a little bit. Let's come up now and click on tangent, click on our circle, click on our vertical line. We now have these that touch only at one point. I want you to notice it does not go through. It rests over here on the side. One of the nice things about utilizing tangent is that if I wanted to get myself this perfect curve right in here, another way to do some geometric construction is I can just create this to be tangent to this line and grab, let's say, this trim tool and trim off the edges. Normally that would just be a fillet, but another way to go about utilizing that geometric construction is to utilize the tangent geometric constraint. Now our next one is the equal constraint. And we're just going to sketch for ourselves 2 circles for this. Let's just sketch out 2 circles. You could sketch out 2 lines if you wished. Really, this is just for any geometry that you create. And I'm going to click on equal. And what I want to do is I want to say I want this circle and this circle to be equal size. And I'm going to right click and say OK. I want you to notice that as I drag on the first circle that we selected, these will stay the same size. They will always be equal. I could do the same thing between these 2 lines as far as their distances. I can say I want you two to always be the exact same distance. And as I drag out, notice that they move together. That's what the equal constraint does. Pretty neat. Next thing is the parallel constraint. A pretty basic, geometric concept of 2 lines being parallel. There's 2 L's next to each other in parallel. That just means 2 lines will never touch. I'm just going to right click and say, okay, we're going to go up to parallel. We're going to click on our 2 lines right here and notice that they will always stay parallel. I can't move them, to be diagonal or to not be perfectly parallel with one another. Next constraint is perpendicular. Let's grab a hold of another line over here, and just somewhere out here in the geometric area, I want to click and just create for myself a diagonal line. Let's click on perpendicular just to understand. I'm going to click on perpendicular and say make this line perpendicular to this line, and automatically it is at a 90-degree angle. I could drag this down to snap, and now we have for ourselves a perpendicular constraint. I would like for you to note that every time we've made a geometric constraint, we see the icons out here on the sketch itself. That lets us know what geometric relationship exists between the 2 different types of geometry. Next thing we'll do is we will say fix. And what fix means is if I say to a geometry, I want you to stay fixed. I want you to stay put. I want you to never move. That means that this geometry now is green and it will never move. So if I grab a hold of the line command, and I say, I'm going to, just create myself a line out here and grab a hold of tangent. I'm going to say I want you to be tangent to you. It's not going to move. It's going to force that line to come to it. I can say I want you, and that's going to force that line to come over. Notice again, you've from some other videos, and if you've made other parts, notice that whenever we have what's called a closed sketch or a profile, that it's a light blue on the inside. And each one of these sketches, if you will, are now surface areas. And Fusion will calculate the surface area. This area out here is staying white because I could pour water in this area and it would spill all over the place. So I always try to think when I see a light blue area, I could pour water inside of this and it would stay inside because it has full boundaries. It has, let's say, a full constraining, a full covering of the edge, if you will. That is what the fix icon does. For our next geometric constraint, you're going to see midpoint. And if I click on this line and just have it out, you can notice that I don't have this right at a midpoint. And I can click on midpoint and I can say I want this to always be lined up at the midpoint of this line, and it just went right through the middle of it and sliced through. I can drag up and drag over, but it just basically took this and cut it right here at the center of that line. That is helpful sometimes for several different reasons. If I wanted to take this and make it flip horizontal, and I wanted to just slice something perfectly at the line, it's not going to snap right to that midpoint, but it's going to slice this object in half. Next is concentric, and concentric means that 2 circles or 2 arcs, let's say, will share the same center point. So think about throwing a rock into a body of water. You would see a ripple effect, kind of the same concept here. So we're going to go up to concentric, and I'm going to click on this circle, and you're going to see they're going to share the same center point now. They will lock in on the same space. I can't move these away from each other. They now share the same center point. I could click on the center point and drag it around, but now this has a geometric constraint. I can see that icon right here, that it has a concentric constraint. Our next geometric constraint is collinear. And if I click on the line command and I say, I'm just going to sketch myself a line here, and I'm going to come down and sketch myself another line, let's say down here somewhere. I'm going to right click and say OK. Collinear means that these now will be on the same line. Collinear. Collinear, if you will. Colline, the same line. They now line up perfectly. Now, even if they don't touch, let's say, and they're off, they share the same, let's say, imaginary line or the same imaginary axis. That is collinear. You can see that line right there. Perfect. Next thing is the symmetry constraint. And what we'll do with this is kind of similar to, let's say, a mirror command. So if I want to come out and just sketch for myself a 2-point rectangle. And I say, you know what, I want this right here to have symmetry with another object. You know, I can make, you know, one of these have, you know, symmetry with another side. I can click on, let's go out and click on the line command. Let's say we want something to be perfectly symmetrical with the other side. So I can say, you know, I want this to be symmetrical with this, and on the opposite side, now it's symmetrical. See how it's from one side to the other, it is going to have symmetry. You'll say that, you know, this line right here is symmetrical with this line, shares the same center point. This line would have symmetry with something on the opposite side of this line right here, if that makes sense. It shares the same line down through the middle. This has symmetry with this line over here. Last one we're not really going to take too much of a look at because it's curvature, just kind of guaranteeing that, you know, different lines have different sketches on. Basically, there's a smooth curvature. It's not really used very much. Generally, I try to stay away from curvature and try to stick more to utilizing the tangent constraint. Now, note that in sketches, you know, sometimes when you create a solid, your sketches are still on. You can always turn on and off your sketches with this little eyeball next to sketches right here. Now, one thing we want to take a look at is, you know, generally you only make drawings of, you know, extruded parts, things that have solids. In this case, we're just going to go to Finish Sketch, and you can place your sketch on a drawing sheet. So I'm going to go up and create for myself a new drawing. It's going to ask me to save this first, and I'm going to go down to my title block that I've created for my class. And when the drawing starts to populate here, you can go ahead and place the sketch on the object. So I can just come out here and click. Fusion's freezing up on me here just a little bit. Just going to have to give it a second. I'm going to go ahead and just pause the video until it comes back. Okay, so Fusion just unfroze, and what I did is I just clicked on the drawing sheet itself. Notice you're not going to see the sketch just pop up, and I'm going to go ahead and say OK. And when I said OK, you'll notice that you have your sketch right here. So I can go ahead and I can just double click on that. I can scale it down the same way I might scale anything else. If I wanted about a half scale, I can go ahead and scale it. Now, you can't edit a sketch here. You know, you can't go in and edit anything, but you can still just place the sketch on a drawing sheet. So just to show you that, you know, you can go in and create a sketch, and if by chance you just wanted to place that on a drawing sheet and you know give it to somebody, that's something you actually could do. So this has been a video for how to go about understanding and utilizing geometric sketch constraints in Autodesk Fusion.